lesson we are going to look at the C sharp application structure. We are going to look at the components of a C sharp application, the organizational structure of a C sharp application, how a C sharp application is organized. A C sharp application is organized into a set of text files that define the types within your application, and then you group or you define those types of your application under a single name, and that single name is called the namespace of your application. Each type that you define within your application has to be defined within a namespace. And after you have defined all the types within a namespace, then the next thing to do is to compile your code. And when you compile your code, the compiler of the respective language that you will be using will produce a physical binary representation of your application, and that physical representation of your application it's called an assembly. So now, depending on the type of application that you will be writing, your assembly will take a different file extension. For example, if you are writing a class library, your assembly is going to take the .dll file extension. But if you are writing an executable application, your assembly is going to take the .exe file extension. Now, depending on the type of application that you will be writing, your assembly it's going to take any of these file extension. The DLL type of application is basically used. It's basically used within the exe files. The DLL assemblies are basically you cannot actually execute the DLL type of applications. You actually make use of the functionality that they provide within your exe types of application. So what is within these files is basically what we are going to look at. What is within this file, generally, it's basically the information about your application. For example, within this file, you are able to tell the version of this application. You are able to tell the company that created this application. You are able to tell the date at which this application was created, the last modified date of this application. But the most important information that you can get within this file is basically the types that are defined within your application and the methods that are defined within those types of your application. Within this application, we are also able to get the set of instructions that are called or termed CIL. CIL is an abbreviation that stands for Common Intermediate Language. This is basically a set of platform agnostic instructions. They are not compiled to be executed by a specific platform, but rather they are understood by the runtime component of the .NET framework, the CLR. They are only understood by the CLR. So then now, depending on where your application will be executing, the CLR within itself, it defines a subcomponent called the JIT. JIT is an abbreviation that stands for Just in Time Compiler. So this is the component that is responsible of taking the CIL and convert them to a platform specific set of instructions. For example, if your application is executing within a computer that makes use of Windows and has an Intel microprocessor, now what the JIT is going to do, it's going to take this CIL and convert them to make use of the Windows features and be understood by the Intel microprocessor. But if your application is executing on a Mac computer that makes use of an AMD microprocessor, the just-in-time compiler is going to take this CIL to make use of the Mac operating system features, and that can be understood by an AMD, because these platforms actually make use of different set of instructions to do the same thing. Does that make sense? So here the benefit is that you write your application only once, but it can be executed or it can be run on different operating systems. So therefore we achieve, through the use of .NET, we achieve what is called platform independent. So you write your application only once, it can execute on all the platforms that have .NET framework installed on them. So now let's look at the simplest application in C# and look at the components that make up that simple application. Cool. Let's look at that. So I'm going to write it on the board. It's basically very, very, very simple. We said the first thing to define when you're writing your application, it's the namespace. Let's term this first application. This is the name of our application. So when we compile this application, we are going to have a physical file with first name A, with the name first ever. So within a namespace, then we can define the types. You can only define types of your application within a namespace. You can't define them anywhere else. You have to define them within a namespace. So let's define the first type of our application. Let's call it program, and this is going to be the only type within our application for now. Now, types defines properties that define the appearance of our type, and the methods that define the operations that is provided by our application. But the most important thing that you must understand is that within the set of types that you define within your application, at least there has to be one type that defines a special method. That special method name is called the main method. The main method is a special method because it is used as an entry point into your application. The .NET runtime, it's going to basically go through the set of types within your application. If you do not specify the entry point of your application when you compile it or when you are running it, the .NET the runtime is going to go through the set of types within your application, looking for a type that defines the main method. The first type that it finds that defines the main method is going to use that main method of that type as its entry point. That is where it's going to begin the executing your application. Or if you define your types and within those types there is no single type that defines the main method, you are going to get an error that there is no entry point. There is no way we can tell we should start executing your application. So this type, which will be the only type within application, obviously is going to have to define that special type of a method. So let's define it as static void main. Let's not define any parameters for now. Let's use this one. So within this main method, all we're going to do for now is to basically print on the console dot write line hello C#. Now we have defined our main method. So this is how a basic application looks like in C#. This is the simplest application that you can have in C#. So to ensure that you do not get any error in this application, it's most important to import this namespace system, because this is where this type is defined, and this type defines this method. Let's not look into details with regards to that for now. But basically, this is the simplest type of application that you're going to have. We have a single type within our application, which is called program. And the program defines this special method there, the main method. It could define other method within itself, but for now it only contains this special type of method. This one has to be there, at least within the set of types that you are going to define within your C# application. At least one of those types should define this main method, because the runtime will use that main method as its entry point, as where it's going to begin executing your application. So this type defines this special type of method called main, and within that main, all we do is to print hello C# on the console, which is the black window that you're going to see when you run this application. Does that make sense? So here, this main method, let's look at the way this method is defined. When you define a method in C#, the first thing that you need to do, you need to define the type of the data that is going to be returned by the method, if your method does return anything to the caller. But if your method does not return anything to the caller, what you must specify, where you would specify the type of data, you specify the void type. The void type actually tells the runtime component of the .NET framework that your method is not going to return anything to the caller after it is finished executing. Then the other keywords that you define, or that you actually specify before the type of the data that is going to be returned by your method, if it does return anything to the caller, are the access modifiers. The access modifiers are used to actually control who can have access to that method. For example, with this one, this method is private because we are not specifying any access modifier. So by default, when you define a method within a type and not specify the access modifier, the method will have the private access modifier. By default, it's given the private access modifier. Other keywords will include this static. This static basically what it does is to actually modify the behavior of this method to be able to be accessed on the class level, not on an instance level. Otherwise, if we remove this static here, what the .NET framework runtime should do in order to be able to call this method, in order to be able to use this method as an entry point, it will have to create an instance of program. It will have to create an instance of program, and then it will be able to call this main method. So the rule is that this main method should be static, so that the .NET runtime do not have to create an instance of the type within which that method is defined to be able to use that method as its endpoint. So you have to make it static. So static is there to actually make this method to be accessed through the class, not on an instance of the class within which it is defined. So the runtime here do not have to create an instance of program to be able to call the main method. It will just call the main method through the name of the type within which it is defined. Does that make sense? So let's continue with that.